All right, here's the second video for section 7.4. Now, because we're going to be looking at adding and subtracting fractions in this section, all the fractions aren't always going to be monomial denominators that are like terms that we're able to just combine together or single terms that we can just multiply together. We're going to have longer polynomials that we're going to have to figure out the easiest way to combine them into like denominators that we can go ahead and combine. So one way of doing that is finding the least common multiple of polynomials. So we're going to have to do this sometimes when we're not quite as it's not quite as evident what our common term is, our common denominator. So there's a couple different ways you can do this. We're going to focus on the first way right now. But what we need to do is you need to know how you can break down your polynomial into the least common factors of each expression. So let's go ahead and look at this first example. So we've got 4x squared minus 16 and 6x squared minus 24x plus 24. Now, let's think back to what the least common multiple means. Now, if we had, let's say, 2 and 4, okay? Let's say, or actually that, well, 2 and 4. Let's say those were our expressions, and we wanted to find the least common multiple of that. Well, the least common multiple, it's very evident, most people can just see it, that it's 4. Now, what we're actually doing is we're breaking down each expression to the product of its least common primes. So 2 is just 2 to the first power, and 4 is just 2 times 2, which is 2 squared. Now, the least common multiple is actually just the product of the greatest exponent of all of the common factors. So in this case, we both have the common factor of 2, but the greatest exponent is 2 squared, which means 2 squared is our least common multiple. Now let's look at another example. Let's look at 2 and 3. So in this case, these are already at their least primes. So this is 2 to the first power and 3 to the first power. Now 2, that's a factor only appears once, so 2 to the first power is the greatest exponent. And 3 only appears once, so that's our greatest exponent. So 2 times 3 would give us our least common multiple, which is 6. Now, if we did something, let's say we did a little bit higher of a number. Let's do 24 and 36. So in this, we're trying to we're trying to find the least common multiple of 24 and 36. Now, we can break 24 down into 2 times, let's see, 2 times 2, and then times 2 again, so that gives us 8 times 3. So 24 can be broken down into, let's go ahead, we want to zoom back out again. So let's zoom out. So we can break this down into 2 cubed times 3. Okay, stick with me here. 36 can be broken down into 9 times 4. 9 is just 3 squared, and 4 is just 2 squared. So 3 squared times 2 squared. Now, what we need to do to figure out the least common multiple, we need to look at each factor and take its highest exponent. So in this case, our common factors are 2, and the highest exponent is 3. So we go ahead and we write down 2 cubed. And we look at our next factor, which is 3. We've got 3 to the first and 3 squared. So 3 squared is our highest exponent. So 3 squared is what we use. So now we take 2 to the third, which is 8, times 3 squared, which is 9. So 8 times 9, and that gives us 72. Now if you look at this between 24 and 36, 24 times 3 is 72, and 36 times 2 is 72. And that's actually, so if you think about it, that is our least common multiple of 24 and 36. And you see how we got that. Now, the reason I did that is it's important to understand that process for finding the least common multiple of these polynomials. Now, I'm going to erase this right now, so it's important. If you should have learned this in Algebra 1. If you didn't remember this or don't remember this, make sure you try out a couple examples of just larger numbers, because it really makes sense after you do it a few times. So you could stop here, pause it, and do a couple examples. Or else if you remember this, let's go ahead and move on. So what we're going to do is we want to go ahead and break down our polynomials into the products of their most factored down terms. So if you look at 4x squared minus 16 and 6x squared minus 24 plus 24, we're going to break this down, and then our least common multiple is going to be the product of each factor's highest exponent. So let's look at this first. Oh, let me forget about this part right now. We're gonna start with step 1. So we want to factor each polynomial. So when we look at our first polynomial, that's just 4 times x squared minus 4. We take out the 4 from it. Now what we can do is 4 is just 2 squared. X squared minus 4 is the difference of squares, so it's x plus 2 times x minus 2. Now, this right here is our most factored down form for our first term. Okay? Now, if you think about it, each of these is just to the first power. So we've got 2 squared times x plus 2 to the first times x minus 2. Now, in our second polynomial, we take out 6, and we have x squared minus 4x plus 4. So we still can factor that. So now 6 is just 2 to the first power times 3 to the first power. And x squared minus 4x plus 4 is just x minus 2 squared. Now, we need to go ahead, and our least common multiple is going to be the product of each factor to its highest exponent. So we look here, we have 2 squared and 2 to the first power. Our highest exponent is 2, so we're going to have 2 squared as our first term. Now, 3 is going to be our next term. We don't have a 3 up here, so 3 to the first becomes the number that we're going to write here, and we get that from this term. Next, we have x plus 2. Now, we don't have an x plus 2 down here, so x plus 2 to the first is going to be our highest factor of this term. And then x minus 2 is our next term. Now we have x minus 2 to the first and x minus 2 squared. This is our largest exponent because it's the second power. That gives us our last term. So our least common multiple is just the product of all of these. So if we take 2 squared, which is 4, times 3 to the first, which is 3, that's going to give us 12. So that's how we get this coefficient right here. And your other binomials, you can just leave them as is. So we get x plus 2 times x minus 2 squared. Okay, so I know that's a lot of steps, but again, if you break that down to the example I gave of 24 and 36, all we're doing is factoring and taking each term to the highest exponent. So what I want to do, I want to show you one more example of that before we move on. I want to look at this extra example too. So let's go ahead and we want to break each of these terms down. Remember, your first step is factoring these and then taking each common multiple. You take each multiple to the highest exponent. So in this first one, we can go ahead and take 6 out, and then we're left with x squared, or x squared minus 9. Now, remember, we can take out 6 turns into 2 times 3, and x squared minus 9 is just the difference of squares, so we get x plus 3 times x minus 3. Okay, so this is our first term simplified. So x plus 3, x minus 3. Now, with our second term, we know if we look at this, we can take a 9 out, and we're left with x squared minus 54. If we take a 9 out, we're left with 6x. And then if we take a 9 out of 81, we're left with plus 9. Now we factor again. If we factor 9, it's just 3 squared. And then when we factor x squared minus 6x plus 9, we're just left with x minus 3 squared. Okay, that's how we factor this. So to find the least common multiple, we have to just take all of the terms from these to the highest exponent. Now, 2 only appears once, so that's our highest exponent. So we get 2. We look at 3 is our next term. 3 appears in both expressions, but the highest exponent is squared. So we're going to have 2 times 3 squared. Now we go on, x plus 3. That only appears once, so x plus 3 to the first power is going to be our next term. So we write x plus 3. Now our last term is x minus 3, which appears in both, but x minus 3 squared, this is going to be our largest exponent. So this is going to be times x minus 3 squared. Okay? So all we've done here is we've taken each factor that appears to the highest exponent. Now, if we go ahead and simplify this, we get 3 squared is 9 times 2, so we should get 18 times x plus 3. That's my parentheses right there, it's kind of ugly. X plus 3 times x minus 3 squared. So 18 times x plus 3 times x minus 3 squared. That's what we should get if we simplify this out. So I want you to go ahead. You can pause this to look at the work. I'm going to give you a question to work on in just a second, but it's going to be the exact same type of question as this. So if you look at the question and have some problems, you can always come back and look at this. Again, I know there's lots of steps in here, but coming back and going through each step one by one and rewatching this should really help you out. Before you just write, I don't know, or I can't figure it out, or write just some answer that doesn't even relate to the problem, come back and rewatch either just the second example or both. Okay, so let's just check and make sure that we did this right. So sure enough, 18 times x plus 3 times x minus 3 squared. We know that's right, so you can always come back and check it. What I want you guys to do, so for your problem, the one that's going to come up that I want you to answer is number 5 here. So find the least common multiple of 5x cubed and 10x squared minus 15x. Go through the steps. So you're doing number 5 in the answer box that comes up right now.